Alright, so now that we know how to solve systems of linear equations, we're going to take some word problems and then put those in terms of a system of linear equations and solve for the variables. So again, this is going to be about word problems. And we're still solving systems of linear equations. This is just, we're going to have one extra step, and that's finding the actual system. So what we're going to do first when we see these problems is we're going to ask ourselves, what are we trying to solve for? So you're going to say, what am I trying to solve for, and assign variables based on that. So first thing we're going to do, say, what am I trying to solve for? Assign some variables. Next, based on those variables, you're going to write down equations. So write down your system of equations. So you're probably going to have two, if you have two unknowns. You're going to assign your variables. From those variables, write down your system of equations, and then lastly, solve. Now how do we solve? We're going to solve doing exactly what we did before. So use your system of equation techniques as before. So I'm going to do two examples for you. So example 1. Let's say that Steph and Chelsea pay $800 each month for power. Steph pays 3 times as much as Chelsea. How much does each pay? So if you need to take a second and stop and pause and write that all down, that's fine. But let's look at this problem. So we have Steph and Chelsea, they're paying $800, not each. That's a mistake there. They're paying $800 every month, not each month. Each kind of implies that each one of them pays $800. So they're paying $800 every month for power. And we know that Steph pays twice as much as Chelsea. I want to know how much does each one pay. So the first step, ask yourself, what is this question asking for? So if we notice here, the last sentence, how much does each one of them pay? So we're asking, how much does Steph pay? So we'll let S be the amount Steph pays. And we're also looking for the amount that Chelsea pays. So those are going to be my two variables. So I have S being the amount that Steph pays, C being the amount that Chelsea pays. Now again, where did those come from? Those are what I'm trying to solve for. So your variables are always going to be, what are you trying to solve for? So I have my two variables. I got an S and I got a C. You already have this written down. We can go back and forth. From the first sentence, let's find an equation. So Steph and Chelsea pay $800. So in terms of S and C, what do I know about those in relation to $800? Well, I know that together they pay $800. So S plus C is $800. Now look at the second sentence. Steph pays 3 times as much as Chelsea. I'm going to try to put that in terms of an equation. Now which one is going to be bigger? Just ask yourself that before you write it down. If Steph pays 3 times as much as Chelsea, which one is bigger? Well, definitely Steph. She's paying 3 times as much. So Steph, the amount that she pays, is going to be equal to 3 times the amount that Chelsea pays. So I have that together they pay $800. That's my first equation. I also know that Steph pays 3 times as much. So now let's solve this. What are we going to do? I already have a variable that's been solved for. That's S equals 3C. So in that first equation, I'm going to replace S with 3C. Now where did that come from? That came from that equation. So I have that 3C plus C is 800, so 4C is 800. Divide by 4 on both sides. I get that Chelsea is going to pay $200. So we'll circle that. That's half our answer. But we're not done. You know how much Steph pays, so I'm going to come back up and I'm going to plug it in. So Steph pays 3 times the amount that Chelsea does. Chelsea paid $200, so Steph is going to pay $600. So there's the other answer. We can always double check. Together, did they pay $800? Well, yes. And is one 3 times the amount of the other? And yeah, and Steph's is larger. So we did get the right answer. So let's do one more of these examples. So this will be example 2. Let's say that we have a movie theater. So at a movie theater, there are adult tickets and children's tickets. Adult tickets, erase that real quick. Adult tickets are $7 each, and children are $3 each. Okay, so I have a movie theater, we have adult tickets, we have children's tickets. Adults are $7 each, children's are $3 each. Okay, so one night, let's say that 400 tickets were sold, and $2,400 was made. How many of each ticket was sold? So again, if you need to pause to write that down, go for it. But let's see here. We have a movie theater. We have 2 different types of tickets. I spelled that wrong. Not an I there. That's me. 2 different types of tickets. We have adult and children's tickets, and then adults cost $7 each and children's cost $3 each. One night we have 400 tickets sold, $2,400 was made. How many of each ticket was sold? So the first step is, what are our variables? So read the question. What are we trying to solve for? Well, if you read this last sentence, how many of each ticket was sold? That's what we're trying to answer. So I'm trying to say how many adult tickets and how many children's tickets. So let's say that A is the number of adult tickets, and let's say that C is the number of children's tickets. So those are the 2 things that we're trying to solve for, so those are going to be our variables, right? Hopefully that makes sense. Now let's go through here and let's try to figure out some equations. So at a movie theater, there are adult tickets and children's tickets. That first sentence doesn't really help us out any, but we've already read through it. Next, adult tickets are $7 each and children's are $3 each. And that isn't an equation, but that is a piece of information. We know that these tickets are $7 each, and we know that these tickets are $3 each. Okay, so we're done with that sentence. Next, one night, 400 tickets were sold. Now let's stop there. In terms of A and C, if 400 tickets were sold, what does that tell us? Well, it tells us that combined, I should get 400. Okay, so together 400 were sold, so that takes care of that piece of information. Next, $2,400 was made. So we know that something is going to equal $2,400. The question is what? Well, let's just kind of pretend for a second. If I sold 5 adult tickets and 2 children's tickets, how much money would I have made? So I said 5 adult tickets and 2 children's tickets. Well, that would be 7 times 5 plus 3 times 2. That's how much money I would make, because it's $7 for each of the adult tickets and $3 for each of the children's tickets. So if we come back over here, how much money will I have made on a generic number? Well, it'll be 7 times the number of adult tickets plus 3 times the number of children's tickets. And that takes care of that one. So hopefully that makes sense. Together we have 400 tickets. Combined, the amount that we're going to make is 7A plus 3C. So my 2 equations, write them down again. So I have A plus C is 400. I also know that 7a plus 3c is going to be 2400. Now we have to somehow solve this system of equations. Now, so it's up to you how you solve it. I would say the first one's going to be a little bit easier to solve. So I have, maybe I'll do this in green here. So we have a plus c is 400. Solve for one of your variables, doesn't matter which one. I'll solve for c. So I get that c is 400 minus a. So far so good. So now I'm going to take that, come back over here, and everywhere I see a c, plug in. So I get 7a plus 3. I'm going to be very careful with parentheses. So there's my 7a plus 3, and then instead of a c I have 400 minus a. And now we just got to solve this for a. So let's see, what should we do first? Maybe distribute. So 3 times 400, 1200 minus 3a is 2400. And maybe pause and ask yourself, what should you do next to solve for a? Well, if I were you, I would combine this term and this term and get a 4a. Then I would subtract 1200. Then I would divide by 4. So I would get that the number of adult tickets was 300. But that doesn't 100% answer my question. I got to figure out how many children's tickets, so to answer that I'm going to come back to this equation. I get 400 minus 300, so the number of children's tickets is 100. Which makes sense. Together, did we sell 400? Yes. Did I make $2,400 off of them? Well, you could multiply it out, but I promise you that you do. So just to recap here, to solve for variables in a word problem, first you got to assign the variables, figure out your system of equations, then solve that system of equations.